Hello chemistry students, Dr. Tullis here. We are looking at chapter 14, acids and bases today, where you will learn about the strengths of acids and bases, how to name them and identify them, and looking at the pH scale. Let's get going on our last chapter.
The career focus for this chapter is a medical lab tech. They perform a wide variety of tests on body fluids and cells for the diagnosis and treatments of patients. They prepare specimens in the detection of cancerous tumors and blood type samples for transfusions, and they interpret and analyze test results, which are then passed on to the physician. Our learning goal for section 1 is to describe and name acids and bases. Acids and bases are important substances in health, industry, and the environment. One of the most common characteristics of acids is their sour taste. Lemons and grapefruits taste sour because they contain acids such as citric and ascorbic acid, which is vitamin C. The term acid comes from the Latin word acidus, which means sour. Arrhenius acids, described by the Swedish chemist Arrhenius in 1887, is a substance that produces hydrogen ions when they dissolve in water. And that hydrogen ion, that H plus, is what we're looking for. Sulfuric acid dissolves in water to produce 1 or 2 hydrogen plus ions and an anion. There are the 2 hydrogen ions that would dissolve in water, that would leave that sulfuric acid, leaving me with S, this is our S, and then O4, SO4 with a -2 charge. That's our sulfate. And there's our 2 H plus ions that would dissolve. Acids have a sour taste. They change blue litmus indicator to red. They corrode metals. And they ionize in water to produce H plus ions. For example, HCl is hydrochloric acid. It's very polar. And when it dissolves in water, we have H plus hydrogen ion, aqueous solution dissolved in water, and our chloride ion. To name acids that are binary, binary means 2 and do not contain oxygen in the compound, we say hydro blank, but we end in an ic, acid. For example, HCl, so it's binary. There's 2 elements in this acid. The first one is always H. We call it hydrochloric acid. So chloride becomes chloric. HBr, hydrobromic acid. Again, we take the ide, this would be bromide, and we make it ic, hydrobromic acid. The acid HCN, now this is not binary, but it does produce H plus ion, and the CN is a polyatomic ion, cyanide. So we still take that ide ending and turn it to ic. So this would be hydrocyanic acid. Acids that contain oxygen, however, like polyatomic ions, if they end in 8, we change the 8 to ic. So similar to this last one where we had hydrochloric acid, hydrobromic acid. Now, the only difference is we don't start with hydro. We just change nitrate, but then when we put so this is the nitrate ion, but when we put a H with it, again, this is a -1, H is always a +1, so this is a balanced neutral compound. We just say nitric acid. Sulfate becomes ic. So in order to make this a neutral compound, see how this is a -2 charge? I would need 2 hydrogens because that's each a +1 ion. So that would be a +2 on the left side and a -2 on the right. Now the only kind of funky part about sulfate to sulfuric, we have to add that So sulfate ion turns to sulfuric acid. Chlorate turns to chloric acid. And if the polyatomic ion ends in ite, we change its acid ending to us. Nitrite turns to nitrous. Sulfite, again, we have to make that sulfurous acid. So the sulfur is a little bit weird. The phosphorus does the same thing. Chlorite to chlorous acid. Again, we still have to make sure that it is a balanced compound. So these are just -1, so there's only going to be 1 hydrogen. But if it's a -2, there's going to be 2 hydrogens. Let's look at some other common acids. These are all binary So we say hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid. HCN is one of the exceptions because there's not oxygen in it, so we say hydrocyanic acid. This shows the anion, which means without the hydrogen attached to it. So we have fluoride, chloride, bromide, iodide, cyanide. Then we get into our oxygen containing, or our polyatomic ions with an H with it. So nitric acid came from nitrate. Ite turns to us. Sulfate, sulfuric, ite to us. Carbonate to carbonic. Acetate, ate turns to ick. Phosphate, here's the one I told you was a little bit funky like sulfur. Phosphate to phosphoric. We have to add that or, phosphor, and then the ate turns to ick. Phosphite turns to phosphorus. So we have to add that or in there. Make sure, again, see how phosphate and phosphite are -3 charges, so I need 3 H's. The halogens can form more than 2 oxygen-containing acids. For chlorine, the common form is chloric acid, HClO3, which contains the polyatomic ion chlorate. For the acid that contains one more oxygen atom than the common form, the prefix per is used. HClO4 is perchloric acid. We would see on our polyatomic ion sheet that ClO4 is perchlorate. So if I add the H in front of it, it would become perchloric acid. When the polyatomic ion has one less oxygen than the common form, we use us. HClO2 is chlorous acid because it came from chlorite, ClO2 minus. The prefix hypo is used when the acid has 2 oxygen atoms less than the common form. HClO is hypochlorous acid. And again, ClO minus we would see as hypochlorite ion. So perchlorate would turn to perchloric acid. Chlorate to chloric, chlorite to chlorus, hypochlorite to hypochlorous acids. Let's look at Arrhenius bases. Arrhenius bases produce hydroxide ions in water. They taste bitter or chalky. They are electrolytes. They feel soapy and slippery, and they neutralize acids. For example, sodium hydroxide is an ionic compound, and when it dissolves in water, it dissociates into our Na plus ions, and OH minus ions are hydroxide ions. Hydroxide-containing bases ionize in water to produce the metal ion and the hydroxide ions. Calcium hydroxide dissociates into 1 Ca plus 2 ion and 2 hydroxide ions. In fact, calcium hydroxide is used in the food industry to produce beverages and in dentistry as a filler for root canals. Here are some examples of hydroxide: lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, aluminum hydroxide. We still need a balanced compound. Remember, this AlOH3 is because aluminum has a +3 charge when it becomes an ion, and OH is always -1. So we would need 3 hydroxides to balance that compound out. Some characteristics of acids and bases. Like we said, Arrhenius acids produce hydrogen plus ions, bases produce hydroxide ions. They are both electrolytes. Acids taste sour and bases are bitter and chalky. Any acid in a cut would sting. Bases, it's soapy, they feel slippery. Litmus paper turns red with acids and blue with bases. If you put phenolphthalein drops in an acid, it's colorless, but once you start adding a base to it, it turns pink. And acids neutralize bases and bases neutralize acids. Let's look at a sample problem. Identify each of the following as an acid or a base and give its name. Why don't you take a minute and see if you can do 1, 2, and then write the formula for each of the following, 1 and 2. Pause the video here and see if you can do it. Hopefully you said that 1 was an acid. H3PO4 is phosphoric acid. NaOH is a base, and that is sodium hydroxide. Magnesium hydroxide would be MgOH2 because magnesium is a +2 ion and OH is a -1 ion, so we would need 2 hydroxide ions. and hydrobromic acid, HBr. Take a minute to look over the review and make sure you understand the learning goal.